So that might be my fault for using Nixos. But anyway, so this talks about generating castles in Minecraft. This is something that I've been doing in my spare time because my kids are really into it, and they're almost at the age where they are interested in sort of code and things like that. It's still too young for Haskell, but maybe by the time they're ready, I'll have simplified this a bit, and who knows. So let's have a look. So the basic idea is to make it easy to build complex structures in Minecraft, automatically generate complex structures, and because it's very laborious by hand, and because lots of the other approaches like Microsoft's bot control, it's a bit like Logo, that's very imperative and difficult to compose, and so yeah, it's very difficult to scale that up to something like a castle. So the general idea is a little domain-specific language that generates these empty function files. These are text files full of very simple commands. And very importantly, I want it to be a compositional language, so we can build complex structures from smaller ones. And it's just a shallow embedding inside Haskell, which means there are no the terms evaluate directly to a data type. And we can also, because it's in Haskell, of course, we don't have to, but we can use all of Haskell's abstractions and so on to help building, to help us build these structures. And yeah, so why DSL is a name that's used quite a lot. You could think of this as just a library, but hopefully it's usable by anyone who is just familiar with basic functions and 3D coordinates. There's no matrices in here or anything like that. I've tried to keep it very, very simple, but being in Haskell, you can make it as complicated as you want. So the basic type is a block, and a block has a coordinate and a kind. There are other attributes that you could add. It does get more complicated than that, but I'm keeping it simple here. And coordinates are all relative, and there is some use of lenses. That's why I've got this template Haskell to say make lenses. And that's why the record accessors of these have underscores there, because we don't generally use the accessors directly. Minecraft structures are a list of blocks, and it's an ordered list of blocks, so any latter block, if it has the same coordinate as an earlier one, well, then it simply overrides that. Why do I have a new type? Well, it helps. Later on, we'll have list of structures. When we do layout and things, we'll have lists of structures. So the new type helps to hide the fact that we have helps to hide the underlying representation, which here is a list of blocks. Here I've got a constructor make blocks. It's just a convenience, really, that will take a list of coordinates and turn it into a structure. It's not needed. Perhaps the only primitive we really need is this 0 one, where we create a block where we create a 0 at the origin of nothing or air. That's probably the only one that's needed. And we set the kind of a block. We can set the kind of the block using this sort of infix hash operator. And to define that, I need to map over block kinds and map over blocks. But those are simple functions to implement. So the basic idea, which I've seen in many other libraries, we have a plotting library that Malcolm Wallace wrote. So it must be maybe 10 years old now. It's a Standard Chartered that does has a non-commutative monoid, and there's a diagrams package in Hackage as well. I think that's Brent Yorgi that did that. That uses a non-commutative monoid as well. But the basic idea is that you can't. It has a different semantic meaning, the order that you append these things up. So 0 appended with 0 hash cobblestone gives you a cobblestone block at the origin. Whereas if we swap the arguments around, if we commute them, then you get a different answer. You've lost the cobblestone. And then we abstract over dimensions using lenses. So it's really, really simple use of lenses, but the idea is that some functions, for example, a centering function, if you were going to center a structure somewhere, you would need to both read a dimension and be able to write to a dimension. A lens is a way of just passing that dimension very simply as a function parameter. We would just say x, center x. And we only ever, in the implementation, we only ever use view over set. And that's about all we need. I'm not going to go through all of these, but in any detail. But to build the composite structures, we use combinators, you see, to provide us with repetition and layout. So we can imagine a repeat combinator that will repeat some modification to the structure a certain number of times. We could imagine a replicate one that built on repeat that sort of moves it and replicates it along a dimension. And so the move here simply moves your structure by a certain amount. The choice of primitives is a little bit arbitrary, and these aren't necessarily the best primitives, but they're the ones I came up with in an evening, and it was very easy to do castle crenellations, for example, by moving 2 as I go along. These are the fancy decorations on the top of the castle. Translate is a composition of move, and that's just a convenience. How would we use these to define a line? Well, a line would be a replicated block of cobblestone. It's 0 hash cobblestone is your is a block of cobblestone, and we would replicate along the dimension, moving 1 each time n number of times. A wall with replicated lines, and a floor is a kind of a convenience function. Well, wall and floor are convenience functions where the dimensions are already picked for you, essentially. Circles. I wanted to, for the castles, I wanted circular turrets and circular roofs and things like that. So had to do circles. This is, of course, really easy. High school algebra, really, but trigonometry, sorry. But here I parameterized it by 2 dimensions. So I can create a circle in a particular plane. There's a number of steps. There's a steps parameter there where I can control how many steps. So, for example, I may not want a solid circle. I may want to place windows. Say if I've rendered a circular turret, I may want to punch windows in it, in which case I would maybe have 4 steps or 8 steps, and I'd go around the circle and punch holes in the turret that way. So yeah, exposing the steps parameter is quite useful. A cylinder, well, a cylinder is just a replicated circle. Here I've replicated it h times, where h is the height, and there it is in Minecraft. A cone is replicated circles, but ever decreasing. Yeah, it makes use of circle. What do we have? Oh, a spiral. So a spiral, I wanted a spiral staircase. So in my circular turret, I want a spiral staircase that the player can climb up. And that again is very simple. It has a certain number of revolutions that you want to do. So you can control the radius, height, and the number of revolutions. So you have to make sure it's not too steep if you want the player to be able to climb up it. And again, steps is exposed. You may want to put torches up the inside of your spiral, torches up the inside of your circular turret. So again, steps might be useful for that. And a spiral staircase is simply many spirals. There is a thickness T, and I'm simply doing spirals, an inner spiral, and then increasing the radius of the spirals. And again, notice I'm using list in all these examples. I'm using list comprehensions, which I think is a very nice way of generating the different steps that are monoid, that are concatenated up. And there is the there is a spiral staircase just rendered in Minecraft outside of a turret, and you can see it's not too steep. A player would be able to climb up that spiral. And grid layout's really useful, particularly for castles. Here I'm taking a list of blocks and giving you blocks back, and I've got a function that adds spacing, an auxiliary function here that adds spacing, and then concatenates them up, and then I map that over all the rows, and then finally concatenate the rows, adding spacing. And finally, this, we need a render function for generating this file, and I'm going to skip the code for that, but it's really just printing out the blocks. That's all. And so that's all. That's basically the code. You know, there's nothing. There's no other libraries needed. But to scale them up to castles, well, some tips, I suppose, were that I found that it was good to create abstract components first and then sort of more specialist versions of them. Otherwise, you're passing dimensions around all the time. Higher order functions useful to parameterize components, like the style of the turret. Yeah, but otherwise, it's just composition. And here's an example of an English castle. I won't give the code for the turrets and the castle keep and so on, but there is a blog post with this on. You can see more of the detail. And here is one of them. This used a random process to introduce mossy blocks to the castle. This is with cones as the turrets, a so-called a Germanic castle, and again by varying the size of the turrets and so on. All of these have little staircases inside as well. As a desert castle. In fact, I don't know if I've probably run out of time now, but there is a I did actually have Minecraft up and running, but there is a to install them in the game. There are you have these things called a data pack. It's very simple. It's a particular directory structure that you can install all these functions into, and then when you're in the game, you see. So here I am in Minecraft. I can reload the data pack if I've written a change to the file in, and then I can say function. Function. It's got command line completion, luckily. And then I get a list of all my Haskell functions that I've generated. So here is the castle one, for example, and I press castle. Oh, I didn't complete it. Here we go. Function, and then it was Haskell castle. That's it. And now I'm standing inside a castle, and then I can go up the. I think we've got. I'm not as good as this as my kids. And we can go up the staircase. If I go up the staircase, I haven't quite punched the windows in the right place. I nearly fell down then. And then here I can fly. I've got cheats enabled. So if I fly and turn around, there we have the Haskell generated castle. And then, yeah, that's all. So.